Hi, in this lesson we're going to look at some more angles rules. We're going to look at now is vertically opposite angles and angles in isosceles triangles. Okay, so we've got two rules to cover. First, we go through vertically opposite lines. This is where you've basically got two straight lines that crisscross each other, and the angles that are opposite will always be the same. So if this is 24 degrees, then x will also be 24 degrees. Again, it doesn't matter how it looks, as long as two lines crisscross each other, the two opposite angles will always be exactly the same. Typical question looks like this. So first things first, we can find the opposite angle. The opposite angle is going to be y, so y is 81 degrees. And now we can also find x and z. How I'm going to use it is if we look here, we've got a straight line. So therefore these two angles here must add up to 180. We can then solve that by doing 180 take away 81. That will tell me that x is going to be 99 degrees. And then again, we've got another pair of opposite angles, which means z will also be 99 degrees. Okay, moving on, we've also got isosceles triangles. We've seen these little lengths before. That means that these lengths are exactly the same. For an isosceles triangle, that will also mean that these two, what we call base angles, are also the same. So if this is 70 degrees, then this is also 70 degrees. Once we've found that out, we can then use that to work out the missing angle. So because this was 70, this was also 70, and now we can use the fact that angles always add up to 180. So if we add together those two angles, it must equal 180. Add together the angles you know, and then take that away from 180. So 180 minus 140 tells me that y is going to be 40 degrees. Okay, and again, normally you wouldn't have been asked to do those in steps, so you can straight away work out x by knowing if this is 81, then so is this. With these isosceles triangles, you always want to look for the two identical angles, and the way you do that is they're going to be the angles that only have one line connecting them. So what I mean is this angle here, x, is next to the two lines with dashes on. That's not going to be the same. And the other two lines that are only next to one line with a dash on, so this one and this one, they're both going to be the same. So take a bit of time to make sure you realise which two angles are going to be the same. Now we've got that, we can use the same fact as before, which is angles in a triangle add up to 180 degrees. So you add up the angles you know, and then take that away from 180, and here x is going to be 18 degrees. Okay, just one more on this type of question. This is probably the hardest kind. So we've got this angle here, and we're asked to work out x. So it's an isosceles triangles, and hopefully you can see that if this is x, that means that this is also going to be x. So now we've got the situation where we've got 1, 2, 4, and then we plus my two lots of x's together. That must equal 180 degrees, again because it's a triangle. So what we're going to do, because we want to work out both the x's, and they're both exactly the same, we're going to take away 124 from 180, and then we're going to halve it. So 180 minus 124, that gives me 56. And again, that was two lots of x. That was both my x angles together, came at 56 degrees, so we need to halve it. And 56 divided by 2 comes out of being 28 degrees, and that's what both these x's are. They are each 28 degrees. Okay, I've just shown you this just so you don't make the mistake of forgetting which two angles are the same. So it's always the base angles. So if you find the corner where the two lines meet, in this case this one, that angle will not be the same, but the other two will. So these two angles are both the same. Again here, these two lines meet at this point here, so these two angles are the same, and you can keep going through. So occasionally people tend to sort of forget which angles are the same, which leads to making a lot of mistakes. And again, don't be confused if like the lines keep on going a bit longer, it's still the same basic idea. I've just basically carried on this line here. Okay, last thing to show is basically what I'm going to call compound questions. That's where we have to use the vertically opposite rule and the isosceles rule in the same question. So you want to work out this angle here. The only angle we know is this angle here is 36 degrees. First things first, if this is 36, we have an opposite angle. So this will also be 36 degrees. Now it's like the last example we just went through. If this is x, then this must also be x. So we do the same trick as before. We do 180, take away all the angles we know, which is just 36 degrees. And then because that is both the x's combined, that's two lots of x, we then must divide it by 2. So if you halve 144, that will give you 72 degrees, and that will be both these angles here. Okay, just finished like a more exam style question. Okay, so we'll combine a few things you also learned in the previous lesson. So here we've got some letters to work with again. So we are told that ABD is a right angle. So again, the way this works, that means if you start at A, go down to B, and then on to D, it's going to be the angle that carves out. So it's saying that this here is a right angle. Okay, which makes sense, it kind of looks about right. And we want to work out the size of the angle EDF. So for that we start at E, we go to D, and then on to F, and it's the angle that carves out. So we want to find this angle here. So the best place to start is start at any angles you know. So let's zoom in on the 32. We know that 32 degrees is part of a right angle. So therefore 32 degrees and this missing angle here must add up to 90 degrees. Okay, how that makes sense? So you want to work out the missing angle, all you need to do is 90 take away 32. And that comes out at being 58 degrees. Okay, next we have an isosceles triangle. Let me just highlight so it's really obvious where it is. So again, for these questions, you want to be looking for these pair of lines, because that'll show you where the isosceles triangle is, and from there you can work out which angles are the same. So that means that if this is 58 degrees, then so is this, because again they're at the base of it, they're not where the two lines meet, and now we can use that to work out this angle here. So right now I don't really care what x is right now, I'm just trying to work out any angles I can, and that will always help me get towards the final answer. So I've got this triangle, and as always, as I keep saying, angles in a triangle add up to 180 degrees. Let's call this y for a change. So we add together the angles we've got, that's 116, and then we take it away from 180. So we do 116 minus 180, or 180 minus 116 I should say. That is going to give you 62 degrees, I hope. 64 degrees. Okay, and then we're pretty much done. We know that y is 64 degrees. Now we can finally look at x, and we can notice that these two angles are vertically opposite. They're two straight lines that crisscross each other, which means x will also be 64 degrees. And we are done. So the same idea, it just merges a few facts together, which is what most of the harder questions will try and do. Okay, thanks for listening, and I hope that helped.